Good evening, bonsoir, Annie. Welcome to Space Trivia with Science North. This program was undertaken with funding from the Canadian Space Agency. So have a blast with us, testing your smarts against other live viewers for a chance to win Science North passes or swag. All you need is a mobile device to play along. So up on the screen here, you can see a web address or QR code. Use those to join. My name is Olathe. I am the staff scientist for Spaceplace and the Planetarium. And our special guest this evening is Dr. Graham Lau, cosmobiologist and host of NASA's Ask an Astrobiologist.
Hi, all. It's a pleasure to join you and to have a chance to chat tonight about some astrobiology and the search for life in the universe with you.
Yes, I'm so excited. All right. So this evening, you're going to have also the opportunity to test your astrobiology knowledge against Graham's, and you can also ask him questions in the YouTube chat. So we're going to monitor that as we go, as we ask you these trivia questions. So let's go ahead and get started. Let's see who's in here. Okay, so see how many players we have. If you are still joining, oh, we've got some players. Awesome. So exciting. Yay. If you're still joining, the instructions are right along the top of the screen over there. So you just need to go to www.menti.com and use the code 22766117. And I think we're ready to play. This is awesome. So glad you guys are here. All right. So this first question. Oh, wait, I always do that. Go back one. We don't want to do question two. Go back. All right, here we go. Are you guys ready? Are you really ready? Okay, so our first question is about astrobiology. So astrobiology is the study of life. I'm looking at this. I can see you guys are not seeing that. See what happens. I reset all slides. Now, Graham, you don't call yourself an astrobiologist. I mean, sometimes I'm sure you do, but you also call yourself a cosmobiologist.
Yeah, that was actually by accident. I am an astrobiologist, and that's the term most of us use. I was creating a blog for Google many years ago when blogging on Google was still the cool thing to do. And the name astrobiologist was taken, and so I just happened upon cosmobiologist, and it kind of stuck, and people started calling me that at conferences and seminars and events, and so I thought it was pretty cool, and so I kept it.
All right. And I mean, it does make sense, right? Okay. I don't know what happened there with my first question. We might have to skip to question two. Really sorry about that, guys. Let's see what does come up, though. And remember, if you answer faster, okay, yeah. So it's the second question. Astrobiologists can do research on Earth. So first question was just like, what is astrobiology the study of? And it is the study of life in the universe. And so here's our second question. Is this true or false that if you're studying life out in the universe, in the cosmos, can you do that research here on Earth? And Graham, have you been able to do research here on Earth?
Yes, if they answered the question, yes, we do a lot of research here on Earth. A lot of us in astrobiology, we come from different backgrounds. Some people are astronomers and planetary scientists, and then some of us, like myself, are geologists. I'm a geochemist. I've gone to a place very high in northern Canada, up on Ellesmere Island, and I've done research here on Earth in Ellesmere. I see a picture of Grand Prismatic Spring in front of us here in this image as well. It's a great place for astrobiologists to do work. There's a lot of places around our planet where we can explore life, even in our own backyards.
Very cool. Okay, but of course we are interested in actually finding it out there in space. We've been hearing a lot about the launch of the James Webb Space Telescope, or JWST. So let's ask a question about that. We know that that telescope is allowing us to look further away in space and time because it's observing in the near infrared wavelengths. But can those wavelengths help us detect life on other planets? Is that something possible? Let's see, there's the countdown. Remember, answer fast. What do you guys think? Is it related? Yes.
Ooh,
Most of you got that. Awesome. Way to go. So yes, in fact, we are. There are. You let me know too. There's a couple instruments that are helping, or a few, with the search for life.
Yeah, absolutely.
Yeah, and we always like to talk about Canada's role. Do they have a role? Do they not have a role? So is it true that Canada built an instrument that's on the James Webb Space Telescope that can help search for life? Is that something we're in on? We know we built the FGS, right? The Fine Guidance Sensor. What does that do? The Fine Guidance Sensor. Do you know?
Yeah.
Are you familiar with that one, Greg?
Yes. So fine guidance, it allows us to kind of hone where we're looking at with the telescope in the first place. And along with NIRIS, which is a near infrared spectrometer, it allows us to get an image of what we're looking at in these large fields of view and then do spectroscopy in one place. And so it's a pretty cool combination of instruments together.
Yes. And the Canadian Space Agency totally had a hand in that. Honeywell did build NIRIS in collaboration with the Université de Montréal and the National Research Council of Canada. So we're in the game, which is pretty exciting. So this is just an image showing the Fine Guidance Center and NIRIS. So they're combined at NASA, at the Goddard Space Center, I believe that's where it was. And it's a pretty cool, complicated piece of technology. So you might have heard of NIRIS, but do you know what NIRIS stands for? So we've got a few options here. They should come up shortly. I think I'm just lagging a little bit here. Let's see if we have any questions for an astrobiologist from our audience. Let's take a look at the comments.
Yeah, I'm certainly happy to answer anything you guys might have about astrobiology and the search for life, including James Webb Space Telescope.
Mm-hmm. Yep, this is just not popping up. Sorry, folks. Let's go ahead and see if the next question will work. And maybe I'll just give it a little pause before I start the quiz. Okay, that one started. Okay, so you can just tell us, what does NIRIS stand for?
Actually, I don't actually know the full acronym offhand. I think you had to tell us.
Yeah, they're so hard to remember. Okay, so near infrared slitless spectrograph. Yeah, so that brings us to like, what's a slitless spectrograph measuring, and why slitless? Is there a difference between like the slitless ones and the ones with slits? Oh, and here we have the answer. Oh, most of you got that. Yes, starlight. So NIRIS is measuring starlight, and it has this slitless spectrograph, which actually lets us take like wide views. So NIRIS isn't just looking at starlight, like it's, well, I guess mostly, but it's not just searching for life. Like it's also telling us the composition of whole galaxies and stuff like that. It can take wide field views, but it has different modes, and so it can focus in on single objects as well, which is kind of cool. So yeah. This is like an artist's impression of a star sort of being transited by an exoplanet. And so you can imagine that starlight passing through the atmosphere of that planet, and then we can analyze that starlight after it's passed through the atmosphere, and we can learn about that planet from that. Yeah. So yeah, we can learn all kinds of stuff, like the composition of the atmosphere, the temperature, the habitability of the planet. And Graham, in your experience, like what would you say makes a planet habitable?
That's a really good question. We don't fully know yet. What makes it habitable and inhabited are two different things. To be habitable for life as we know it, life as we know it requires water as a solvent, as a liquid for life to process chemical reactions, life as we know it is based on carbon chemistry. We have a carbon backbone, and many of the organic molecules, I mean, that's what organic molecule is. It's a carbon backbone molecule. But there's a lot of other possibilities out there too for life. People have talked about silicon-based life and maybe life living in different solvents, like liquid ammonia or supercritical carbon dioxide. So there's a lot of possibilities.
Yeah.
But one thing that we're really looking for when it comes to worlds that could be habitable, we're looking for worlds that are somewhat like ours, so that may have surface oceans. And so we look at this place called the Goldilocks Zone. It's the region
don't
around.
give too much away about the Goldilocks. I'm going to ask some questions about that.
I won't give away too much about it then. Maybe we can wait on that. I do see there were two questions that came in. One from Anna Oroshenko.
Mm-hmm.
Did we find anything yet? And the answer is, well, yes, we found lots of stuff, but we haven't found any evidence yet of alien life. And so we're still looking for that. And then Zishan Ayub asked, how exactly are scientists expecting to detect life on planets in other galaxies? Zishan, we're really not right now. We don't really have the resolution. Even the James Webb, JWST, is the highest resolution of a telescope in space we've ever built. And it can look at these galaxies super far away. That first wide field image showed us galaxies up to 13.5 billion light years away. It's really, really far away. But we really can't resolve the atmospheres of the exoplanets in other galaxies yet. And indeed, we only actually have one likely detection so far that I know of an exoplanet in another galaxy. Most of the worlds we found, of the 5,000 plus that we've confirmed so far, they're mostly around our solar system right here in our galaxy.
That's awesome. Okay, I just got a question through Mentimeter. What does the micrometeor damage from a few months ago mean for the James Webb Space Telescope? Will there be more strikes? And did we lose any potential findings because of it?
Yeah, so 3 questions. So for those who don't know, so we detected one of the mirrors was damaged by micrometeorites. These are small pieces of rock and dust in space, and they're everywhere. They impact the space station, they impact Hubble. But where James Webb is at, it's out beyond the orbit of the moon. It's gravitationally bound to the moon and Earth together, and so it's never going to see Earth light ever again. Where it's at, it's never going to see us. It can't see us. And so where it's at, it's even more likely to be struck by these micrometeorites that are out in space. And so we detected a small bombardment of some particles. They hit the telescope. They did a minor amount of damage, nothing to really hinder further observations. They tested it. Everything's fine. But this will happen again. Through time, as it continues to age, it will slowly get broken down and beat up more and more by micrometeorites. It should have a very long lifespan, but over time, it will slowly degrade the measurements we can make with the mirrors since they aren't protected.
Mm-hmm. Okay, but we're going to observe a lot in the meantime, and we're looking at exoplanets in our own galaxy, and we're looking for something we call biosignatures. Of course, you also mentioned that there are techno signatures that we could be looking for. So maybe we could talk a bit about that while people are answering this next question. 7 out of 20, almost halfway there. Which gas is not a good indicator of life, aka a biosignature? I think I've done the thing again where I hit start quiz too soon after switching the slide. I think this is causing me not to be able to actually ask you this question. I'm going to get the hang of this. Okay, I'll maybe try one more time. And I'm going to wait a little bit till it actually loads. And then I'm going to start the quiz. And it's going to work. Yes. Okay, so there's the question. So biosignatures can be gases, right? We're looking at the composition of atmospheres. So I've given you a big long list of gases here: oxygen, carbon dioxide, methane, helium, ammonia, phosphine. If you took the time to read the last slide, there were some hints in that. But which of these gases is not a good biosignature? And what would a techno signature be? You mentioned techno signatures.
Yeah. Interesting answers there. It's coming up pretty even, it looks like. Yeah, so biosignatures, signs of life. These are patterns, processes, the materials that we can find out there that are indicators that life is present or was present. So a fossil, if you're out for a hike and you find a fossil in a rock, that's a biosignature. It's a sign of a life that was once there. The same way that if we can measure some gases being inhaled or exhaled by creatures, those could be signs of life as well. And so it's really interesting that we had a good number of people say that carbon dioxide is not a good biosignature.
Maybe because it's like threatening life on Earth a little bit.
That could be, yeah. But it's possible that there is other life out there, just like life as we have it, that the carbon dioxide is part of its respiration process. We could find a lot of carbon dioxide in an atmosphere that could lead us to think that there could be signs of life there. And a lot of times what we're looking for is the mixture of different potential biosignature gases together. And also, if we can get really lucky and get a bunch of data over time, if we can see changes in those gases over time, that also really helps us a lot too.
Yeah. Okay. So here I have this was my little hint in the left side, this very sort of blurry image of a helium atom. So it's one of the noble gases. So those are really, I was kind of doing a little bit of research. This isn't my area, but it seems like the noble gases are kind of the only ones that really aren't produced by life forms. Is that?
Yeah. So, and when I was a kid, we called those inert gases. And that name has changed now. We prefer to call them noble gases, which has been around for a long time, but we don't really say inert anymore because it turns out that there are some chemical reactions that the noble gases can take part in. But in general, they don't react. They don't take part in many of the chemical processes that we see out there. And to our knowledge, they're not used by life for any process. And so we have argon in our atmosphere. We're constantly breathing in argon and breathing it back out, and we don't react with it at all. It's just there. And helium too. There's actually becoming a helium shortage here on Earth. I don't know if you've heard of that. We have a certain amount of helium inside of our planet, and we mine that helium out. We take it out. We make helium balloons, and we like to play with it and bring it into our throats so we can hear our voices change and go super high pitched. And then that helium is lost to the atmosphere, and over time is slowly escaping to space as well. And so we're actually losing helium from the Earth.
And one cool thing about argon, you mentioned argon, we use argon in the search for dark matter, but that's totally a whole nother issue. So next question. Phosphine was on that list. And is the phosphine that they detected in the atmosphere of Venus compelling evidence that there is life there on Venus?
Ooh.
It's possible that it could be one, right? And again, what about those, what we're giving people some time to answer this, what about the techno signatures? What would those be?
Yeah, so we talked about biosignatures. Those are a sign of life, past or present. A techno signature is a sign of technological activity of life. And so we humans, we produce techno signatures all the time. If you get into an airplane and go for a flight and look down, there's a very good chance that you're going to see some crop circles. By human farmers. We've created all these different crop circles and crop structures in our farms and our fields, and all of these structures around our towns and our cities of roads and construction. Those are all techno signatures. They're signs of technological activity. We can look out into the universe and maybe we'll find signs of technological activity out there as well. Maybe someone else will be making some rock and roll alien music and sending it into space. Or maybe we'll find signs of industrial activity on one of these exoplanets. Using
carbon dioxide.
Yeah. It could be carbon dioxide. It could be something like chlorofluorocarbons. There's a lot of possible things that can be produced that
those
could
things
be a
that
sign.
we're eating the ozone layer, right?
Exactly. Yeah, we used to produce a lot of those, and then it's actually it's interesting in our past, this time when governments actually came together and did something good for the planet together as a whole governing body of the Earth and decided, no more chlorofluorocarbons. We're going to save the ozone, and we really did. We
totally dealt with that. Yeah. And now they're meeting again because the chemical that they used to replace the chlorofluorocarbons is actually a really powerful greenhouse gas. And so they're like, oh, wait a minute, okay, let's get back together. Let's come up with something new that's also not a greenhouse gas. So they're all over that, which is awesome, and does show that as a global community, we can make these changes, which is awesome. Okay, back to the quiz. This is an interesting one because a lot of you thought maybe there's evidence for life on Venus, and of course this is something that's debatable. Graham, what are your thoughts on life on Venus?
Yeah, so the phosphine detection or possible detection is interesting. It comes from telescopes based here on the Earth. The first was the James Clerk Maxwell Telescope in Hawaii. Jane Greaves and her colleagues, they found this little absorption line in their data showing that there could be phosphine in the atmosphere of Venus. And so they used a much more powerful telescope down in South America called the Atacama Large Millimeter Submillimeter Array. And they measured the exact same little dip in the data, that same absorption line. And so they calculated based on their data that there could be some decent amount of phosphine in the atmosphere of Venus. So phosphine is a gas. It's a phosphorus atom with 3 hydrogens bound to it. It's very similar to methane. Methane has 1 carbon atom with 4 hydrogens bound to it. Phosphorus is phosphine is 1 phosphorus with 3 hydrogens. We've found phosphine in other places. We've found it in Jupiter and in Saturn, and so we know it's there. And we also know chemically how it can form without life on those 2 worlds. But on Earth, the only places we find phosphine, if we find it, we can make it in the laboratory without life. But if we find it in nature, it's made by life. We find it in places like bogs and swamps from the decay of biological material. We also find it in penguin poop. And so penguin poo is like a great place to find phosphine and measure its off-gassing. But finding it on Venus could be really important because right now we don't know how it could form without the presence of life on Venus. Now, that said, a lot of people have debated this. One, they've been debating whether the phosphine is even there in the first place. And they've also been debating whether it has to be life. There's so much we don't know about Venus yet. There could be geological processes that could be an explanation for phosphine that we haven't been there enough. We haven't explored Venus enough to really know.
Okay, so did I kind of get this one? Like, would you say the evidence is compelling or not compelling at this point?
Ooh, I would say that the evidence is compelling that we should give more money to funding Venus missions. That's what's compelling. Yeah, we need more missions to Venus. That's what we need. And then we can start really saying whether it's compelling that there's life there or not. There are some people who are really convinced there's life in the Venusian clouds. And then there's a lot of people who are very much like, no, there can't be any life on Venus. I'm personally somewhere in the middle.
So okay. I kind of felt like the main consensus came down on no, that could be explained in a lot of other ways, but this is super fascinating. It would be amazing to find life on Venus.
Yeah, okay. Absolutely.
But we're also super curious about the other exoplanets, other planets outside of our solar system. We are using the James Webb Space Telescope for that. So we're almost to the middle. This is a question about, so we know Canadians are involved with Jwst, and how many hours of observation do you think we're getting for our contributions? 4 hours, 45 hours of observation, or 450 hours of observation? And Graham, maybe you could explain a bit to the audience, like how that works, like how it works with space missions and the time you get.
Yeah, so it happens with ground-based telescopes and observatories on Earth the same way it does with space-based telescopes. There's a process by which scientists basically they submit a proposal for time, requesting a certain period of time to make certain observations using the telescope, and then there's a review panel that basically decides like who has the most compelling proposal, who deserves the time, how do we allot the different amounts of time. And then, of course, those who help to build the instruments and help develop all the science going into it, they get certain allotments of time as well already planned out before the thing even launches. And so there's that way that we use basically to build out how we're going to structure all of the time the telescope spends looking at different things.
And we got a good comment, which was just saying, I didn't give a context how many hours per year, per month, but it's sort of the total, like they're guaranteed that for the life of the telescope, but if it lives longer, we'll get more kind of thing, right?
Yeah, and so just like, every single mission that gets launched into space has an optimal lifespan. I actually don't know offhand what JWST's is, but every mission goes to space. We have this is its lifetime, and if we get longer periods of time, that's fantastic. But and depending on the kind of mission that we have, sometimes those lifetimes are very short, hours or days. And then sometimes they're very long, years or decades.
Awesome. All right. Okay. So we're on question 10 of 20. We're almost to the halfway mark. This one is about, oh, and we do have a question coming up. Can the JWST, oh, where is that? It disappeared from the thing. I will find it in a second. First, we'll ask this question. Do we have any results from NIRISS yet? Yes or no? You probably know this one, Graham. I won't actually get you to give it away yet. And when we're talking about results, of course, we're just talking about like having looked at the atmosphere of an exoplanet. And yes, that has happened, which is very exciting. But before we dive into those, let's take a look at our leaderboard and see how everyone is doing. All right. So at the top, we have Spacey Lady. I feel like you've been here before, Spacey Lady. I remember that name. With 6,650 points. Well done. You were the fastest at answering these questions. Next up is Suzanne Morrison, followed by Glenn. Remember, you are playing for the chance to win Science North passes, or if you're already a member or you live really far away, you can get some swag instead. We are only halfway through, so you do have a chance to pull up and take the lead. And here we go. Let's get right into it. So the first question is something probably for like the hardcore space geeks here who've been following along. But which exoplanet did NIRISS observe? So was it Hornet 83A, B21C, or WASP 96b? Now these are kind of like funny names. Like how do you know how exoplanets get their names? Like where these names come from?
I don't know all of them. Most of the names come from basically the telescope, or the program, like the project that was involved in multiple telescopes together doing observations. And so for Kepler-based confirmed planets, they'll have K or K2 as part of the acronym. I don't know what WASP offhand stands for myself, but so for a lot of the exoplanets out there, though, the naming comes from the campaign basically that found that planet.
Right. So yeah. So WASP, I looked it up. It stands for Wide Angle Search for Planets. I love how straightforward astronomers are. It's awesome. They're black holes. It's the summer triangle. It's the Wide Angle Search for Planets. And a lot of you knew that. That's really cool. Yeah. So WASP 96b. And here we can take a look at those results. So this is a hot gas giant. We can see some spikes there that are labeled water, H2O. But let's think about like what else this graph might be telling us. I have a question about that. And I also have a question through Mentimeter. Can the JWST photograph potentially habitable planets, or is it mainly for scanning stars? Okay, so yeah, so what it's doing is it's looking at, you can kind of see the background image behind this graph, is it's looking at the starlight that has passed through the atmosphere of the planet. It's looking at the spectrum of that starlight. So it's breaking that light down into each wavelength that comes through. So you can see at the bottom of the graph, those are the wavelengths. So we have shorter wavelengths on the left, longer wavelengths on the right. And we're looking at the starlight that's, telling us about this planet. So, and that kind of brings us to the next question. Start this up. So when we're looking at those peaks, the height of the peaks, they're helping us determine, and here's is it the temperature, the cloud cover, or both? And again, this might be for those of you who are like a little deeper into the subject. And you can see they kind of like trail off towards the left. So that's actually telling us that there's probably some haze in the atmosphere, and those lower, the shorter wavelengths are getting scattered. Awesome, you guys got that. So it's both, yeah. And so that information, it's one thing we can get from that is that there are clouds in the atmosphere, and that the temperature of this planet is about 725 degrees Celsius. So we saw water, we associate water with life, but what do you think? Do you think there's life there if it's a gas giant that's 725 degrees Celsius? Yeah,
it's pretty hot.
Yeah, what do you think, Graham?
Yeah, I don't know what the audience thinks, but that sounds pretty warm to me.
Yeah.
The highest temperature we know of any organism on Earth surviving is 122.5 degrees Celsius.
Oh, wow. So that's a big difference.
Yeah, it's a pretty big difference. That's like the surface of Venus, practically. That's very hot.
Oh, but we think that there might be life on the surface of Venus, right? Even with all the acid rain or in the clouds of Venus?
Yeah, so the clouds are a little different. So around 50 kilometers up on Venus, the clouds get to be about the same temperature as the surface of the Earth, and the pressure is about the same as at sea level. Whereas down on the surface of Venus, it's a much different story. The temperatures are very hot. And based on our current knowledge of the physics and the chemistry of life, it doesn't seem very likely that there's anything that we know of that could survive and still have chemical reactions occurring on the surface of Venus or in a very hot world like that.
Mm-hmm. All right, that's cool. All right, so we haven't discovered extraterrestrial life yet with JWST. I think it's pretty safe to say they're still analyzing that data. It's just fresh in. But we have a lot of other places we can look, right? So here's a question, and Graham, I think you let this slip earlier, which is always kind of a fun part of this. If you're listening closely, sometimes you get the answers. But how many exoplanets have been discovered? Like, have we confirmed actually exist? So is that 5, 512, or 5,125? What do you guys think? How many other planets are out there just in our own galaxy? What do you, yeah.
And I think it's pretty cool. When I was a kid, it was 0. It was 0 when I was 5 years old. I know that one of our audience members earlier said that they have a 5-year-old watching with them. And I'm sure there's other families and young people watching who now live in a time where there's thousands of worlds that we know of.
Wow. That is very cool. Okay. Our producer, the lovely Renata, has just let me know there are some questions over in our YouTube comments. Let's see what we can find there. And well done, guys, on getting that. A lot of you knew that was over 5,000. Okay, here's one from Sue. Do any of the 7 planets in the Trappist system potentially indicate significant biosignatures, given that they are in the Goldilocks zone? Ooh. Okay, can we come back to that one? Because I don't. If anyone doesn't know about the Goldilocks. I don't know.
I almost gave that away earlier too, so maybe we should wait for a minute.
It's like a key thing. Let's come back to that. Let's go to our because I don't know, this kind of relates. All right, so here we go. So wait a beat, start the quiz, answer fast, get more points. If you want to join in just for fun, those instructions are at the top of the screen. Okay, so our question is: the habitable zone is your couch, a zone with confirmed inhabitants, or the distance from a star where liquid water could exist. So I know we've kind of maybe touched on this a little. Let's see how we do. And yes, well done. That is the definition of a habitable zone. Okay, so we've got 7 planets in the Trappist system. I think the Trappist system was definitely a target for JWST. Mm-hmm. But I don't think we've looked for the biosignatures yet. Is that?
We've not released the data yet, to my knowledge. I'm pretty sure the team who had the time to look at Trappist have already had some time. I don't know when those data will be released and when they'll be processing the data and talking about them, but the coming year, 2 years, 3 years with JWST, it's all going to be incredible and exciting with every single data release that we get. But for those who don't know, so I will say I do personally prefer Goldilocks zone. I love the connection to the nursery rhyme, the old fable. And also there's nothing about the habitable zone that necessarily says it is habitable. Mm-hmm. But it is the place where there could be liquid oceans on the surface of a terrestrial world, so a rocky world, if its atmosphere isn't too thick or too thin. And it's not too small. So if it's like a Mars-sized world, it could actually lose those oceans because it lost its atmosphere, and then the oceans can get stripped away. If it's a Venus-like world, it could have such a thick atmosphere, it boils all of its oceans away. Mm. But if it's an Earth-like world with a decent-sized core and it's not too old, it could have liquid oceans at its surface, which could be a place for us to look for life. And so the Trappist system has 7 planets that we know of so far. And 3 of those planets are inside of that Goldilocks zone. They're in that region where a world could have standing oceans of liquid water at its surface. And so those 3 worlds are really good candidates for us to look at in looking for biosignatures. But just being in the Goldilocks zone by itself isn't necessarily enough to say that there could be life there. We need more data. And so using NEAREST and using JWST, it gives us a chance to actually look at those atmospheres. And by the way, like looking at an atmosphere of an exoplanet, I mean, we are literally looking at that little itty bitty outside veneer of gas on the outside of a world as starlight passes through it, as it passes in front of its star. It's incredible to get those data.
Yes, absolutely. Okay, so and it's not just like what type of planet, right? But also what type of star, because there are different types of stars. And so that kind of leads to the question, what type of stars should we focus on in the search for life? Because we're going to have to point at the star and then find the planets and then get a transit and look at that starlight passing through. So should we be focusing on ones like our sun, like the G stars, or stars cooler than our sun, so like the K dwarf stars, or stars much cooler than our sun, like the red dwarf or M stars? Well, it's kind of a tricky question, right? Because intuitively you would think we would want to look at ones like our sun, like kind of like we want to look at planets like Earth, because there's life here, right? So it's a good example. But what we find is that actually it's those K-type stars. Now, this is something I found Googling around. Would you agree with this, Graham?
Yeah, so I always like to say we don't know. What I always end up coming down to is we just don't know. There's so much possibility. But what we really have to consider is plausibility or probability for life out there. And so if we're looking at like a really big star, like a giant, like a blue giant or a red giant star, those stars are either about to go out of existence and basically blow up into form a supernova and then shrink down to a white dwarf, or they were born, these giant stars, in which case their lifetime is very short, millions of years in some cases, tens or hundreds of millions of years. And so the time that it takes for a planet to form, for life, at least how it happened here on Earth, for life to not only originate but evolve to become kind of the life that we know that has diversified with the planet, that takes some time. And so maybe stars and planetary systems that live less than 1 billion years or less than 100 million years just aren't good places to look, because there's not really enough time for life to really evolve and start kind of interacting with its atmosphere. But then we look at things like K dwarfs and M dwarfs. There's not only so many more of those out there in the universe, and most of the stars are M dwarf stars. And so we have more and more of the stars that they get smaller and smaller just because of the physics of how stars form. But then we also have an issue. So some M dwarfs, for instance, people are now wondering, they have Goldilocks zones that are very close to the star because they're much cooler stars. But that also means that they're so close to the star that if the star has a solar flare or any material being blown off, it's actually bombarding those planets in that Goldilocks zone fairly often.
Yeah.
Now, is that good for life or bad for life? For life as we know it, humans, we don't do so well with giant globs of radiation falling on top of us. But who knows?
Yeah. So that's one of the reasons maybe the K-type stars are better. And then also, that long lifespan. So like around 40 billion years, whereas our sun is only expected to live for 10 billion years. So we're about halfway through the lifetime of our sun. And then it's going to, expand into a red giant and actually make Earth not habitable anymore. We won't be in the habitable zone anymore when that happens. So, but that is a long way away, and probably our best bet, maybe one of our best bets for actually like finding life might be back here in our own solar system. It's definitely a place we can reach, we can actually travel to. So in thinking about that, and we were talking a bit about those habitable zones and the definition of a habitable zone, is Mars in the habitable zone of our solar system? I've given another yes, no here, like Venus. So again, we're talking about a place where there could be liquid water on the surface of the planet, given the planet having sort of the right characteristics. So let's see. All right. So with this one, I made both answers right.
That's a good call.
Yeah. So we think that at one point, this is like an artist's impression of what. Oh, I'm sorry, my screen is not looking beautiful. Let me fix that for you. Okay, I think that should be better. So this is an artist's impression of what Mars may have looked like. So you can see Valles Marineris there filled with water. And we don't think that was a formation created by water. We think that's like a crack in the crust. But yeah, Mars might have looked like this one. So it might have been in the habitable zone. And Graham, do you want to tell the story about like why Mars doesn't look like this anymore?
Yeah, so we have so much data to show that Mars had a lot of water at one point in its past. We see the structures that are formed by water, valleys and deltas. We're exploring one right now with the Perseverance rover. We see these places where water was standing in lakes. There's even a region in the northern hemisphere that might have had a large sea or even an ocean at one time in the distant past. But as I was kind of mentioning earlier, Mars, it's very small and it has a much smaller core than our world. And so it's dynamo. So here on Earth, we have a dynamo, a magnet basically inside of our planet that protects us from solar radiation. It also allows us to have the northern and southern lights, the aurora borealis and aurora australis. That happens because we have a magnetic field that guides particles and radiation from the sun back to the Earth. And we see it kind of interacting in the atmosphere, making these beautiful greens and reds and things. Mars doesn't have that. Mars doesn't have a large dynamo inside anymore. Its core has cooled down so much that it's no longer producing an innate magnetic field, and it hasn't for a very long time. And so over time, and we actually have a spacecraft at Mars helping us measure this right now. It's called MAVEN. It's been there for many years doing research on the atmospheric loss, the volatile, as we call it, loss from Mars, to show us how Mars lost its atmosphere and probably lost its water over time, as basically the sun's radiation was striking it and just removing the atmosphere faster and faster. And so the ocean, two things were likely happening at the same time. One is that the ocean was being lost to space as hydrogen and hydroxyl from the H2O in the water were being pulled into space. And then a bunch of the water was also being sucked down into the ground and making permafrost as it got cooler and cooler on Mars. And the average temperature on the surface of Mars is negative 90 degrees Fahrenheit. I forget offhand what it is in Celsius, but the surface of Mars is very cold on average. And so it has a very thick layer of permafrost. And so a lot of the water also, we think, got buried down inside the surface of Mars.
Mm-hmm. Yes. And so, I mean, my research was on bringing life back to Mars, potentially, if it was there, it could have been. And so do you think we would have to, something we've talked about is having to like recreate a magnetosphere to protect a new atmosphere? Do you think that might be possible?
Yeah, I mean, who knows? The future is ours, right? And so there's a lot we could do with Mars, and who knows? Maybe soon we'll have humans setting foot on Mars for the first time. Maybe in our lifetimes we'll see the very first human settlement on Mars, of humans starting to live and explore Mars together there. But for the future, for things like terraforming Mars, for creating some form of artificial magnetic field, for forcing the surface to have a world more like we know it here on Earth, with a thicker atmosphere, with protection from radiation, that's a very long way away if that happens.
Yeah, and that's cool that you brought up the exploration, like maybe late 30s, early 40s. We're hoping to get people there, and we are preparing for that with the Artemis program, which Artemis 1 is scheduled to launch August 29th this month, returning to the moon. Really exciting. No people on board yet. By 2026, we are hoping to land people back on the surface of the moon in preparation for going to Mars, as well as doing more scientific research on, the formation of planets and moons and our solar system. So all really exciting stuff. All right, but back to the quiz. I know you guys are eager to answer some more questions. We only have a few left now. So thinking about our solar system and places that we can reach, we know Mars, we know Perseverance is looking for signs of past life on Mars. We don't expect to find present life on Mars. Venus is very debatable if there's life in the clouds or not. But are there, is Earth really the only place that we would expect to find extant life in our solar system? Given, all the things. And okay, time's up. Oh yeah, you were pretty divided
Interesting.
But I mean, I would say no, right? Would you agree, Graham?
I feel like the answer here is no. I don't actually know what your next two questions are, or next three questions, so I don't want to give anything away.
Okay, yeah. Okay, yeah, we'll forge ahead.
Yeah.
We've been talking a lot about planets, especially the exoplanets out there in the galaxy outside of our solar system, but moons can also harbor life. So let's talk a little bit about moons. This first question is just to sort of test your knowledge. How well do you know your moons in the solar system? It's one thing to be able to name the 8 planets and perhaps even the 5 dwarf planets, but how about the moons? So here's a question. Enceladus is in orbit around which planet? Mars, Jupiter, or Saturn? What do you guys think? A couple more questions to answer. This one's for like the really hard. I even forget this. I always have to go back and look it up again. It's for the really hardcore space nerds.
Well, there's so once we hear the answer here, I can tell you a fun fact of why you'll remember this from forever now moving forward.
Okay, that's awesome. Thank you.
Yeah. So the answer is Saturn. I see it just popped up.
Yeah.
So yes, Enceladus is a very small moon actually orbiting around Saturn. Enceladus is this really cool place where we see water erupting in giant plumes from the southern hemisphere of this moon. Now that's cool for a few reasons. So for astrobiology, it's very cool because there could be signs of life potentially in that water. But how you will always remember this is Saturn, and how you'll always remember this now moving forward. Think of Saturn's beautiful rings, all of those rings. Well, there's one really big ring. We can't see it with our own eyes. If you looked at a picture of Saturn, you won't see it. It's a really, really big ring of Saturn called the E ring. That ring is being formed by the water that's erupting out of Enceladus. So without Enceladus, there is no Saturn rings. This large E ring is part of what builds up the inner rings as well. It's all connected. And so whenever you think of Enceladus, think of the E ring of Saturn, and it's very connected from the water coming out.
That's very cool. And I can see, though, why people might say Jupiter, because there is also a moon around Jupiter.
One of my favorites.
Yeah. Okay, so here's another. This one is a which moon is not a good candidate for finding life. So we've got Enceladus, which I think you gave that away, Graham, which is awesome. If everyone's listening, Phobos, Deimos, or Europa. So which of these moons is not a good candidate for finding life? And of course, Phobos and Deimos are around, you know this, I'm sure. Mars, yes. So they are fear and dread, the children of war, Mars being the god of war. And neither one of those are good candidates for life. They're very small. They have no atmosphere. There's no water. Nothing's going on there. But Enceladus around Saturn, the E-ring that Enceladus is helping to create, and Europa, which is around Jupiter. I don't have any good ways to remember that yet. I guess just not Saturn.
Yeah, I mean, so and Europa is just one of my favorite moons. It's one place where I think we should look for signs of life. Yeah, so this is an image showing Enceladus. We can see down in the very bottom of this image, you can see those plumes of water erupting out of the southern region of Enceladus.
Very cool. Yeah, I'm sorry, I don't have a picture of Europa to share, but.
Yeah, well, I mean, so I can say, so like the general structure is very similar.
Yeah.
So just like Enceladus has this icy crust, and then down below that is what we now think is a global ocean. We didn't know for a long time. We weren't really sure. Now, based on all of our data from the Cassini spacecraft, we think it is a global ocean under that icy crust. Wow. But again, Enceladus is a very small moon, and so its ocean won't be very deep. But with Europa is about the same size as our moon. It's a very big moon in the solar system. Its icy crust is maybe 10 kilometers or so thick, we think, based on data from the Galileo spacecraft, which is at Jupiter. And then its ocean might be 100 to 120 kilometers deep. That's way deeper than any of the oceans here on Earth. It's deeper than all the ice we have on Earth. And so there's so much of a volume of fluid in that ocean. It really makes us wonder what's going on down there.
Oh, here's an interesting question. Is there any genetic evidence on Earth of possible alien origins? So I'm not sure if that's what, there is like a question like the alien origins, like there's some theories that maybe because Mars was maybe it was habitable before Earth was, because Earth was still cooling off. So there's some thoughts that maybe life like got knocked off Mars and landed on Earth, but like have we found any evidence in our genes of alien?
Yeah, we definitely have not found anything that appears alien. So there was a paper published by a rather questionable group who they had to create their own journal basically to publish a lot of their findings because they couldn't get past peer review because a lot of scientists were pointing out flaws in their data. But a few years ago, they did get a paper through one journal claiming that Octopus DNA was alien, which is kind of absurd because we can look at Octopus DNA. It has the same kinds of molecules, the same kinds of genes. They share actually almost all of their DNA is almost the same as humans. I mean, all of us animals share a lot of the same DNA. Just like us, like 50% of a banana's DNA is the same thing.
Yeah.
And so there's so much similarity. And then, using phylogenetics, which allows us to look at the genes of every organism we can measure and compare them to each other, we can actually plot octopuses together within the tree of life as we know it. And so far, we don't know of any aliens that are out there on Earth. However, that said, there's a really cool hypothesis called the shadow biosphere hypothesis, suggesting that there could be some form of life right now on Earth that we don't know is here because we're not measuring it. So,
like dark matter.
Yeah, so basically a dark biological matter.
Wow. That's so cool.
So
I have not heard of that.
There could be some kind of like viral life forms or microbiota, microorganisms out there that might not be using DNA and RNA. They might not be using the same kinds of molecules that we do, and so we don't measure them. And so that would be very alien and very weird if we found that. It wouldn't mean it's not Earth life, but it would be very different from our life. However, we have no data yet to suggest that it's actually there. It's just a hypothesis that it could be there.
Yeah. And I mean, we're still discovering new things. Like my 11-year-old just told me all about like gyruses a few months ago, that there were these giant viruses that we just discovered. And I'm like, I don't know. But he like he convinced me, showed me. So yeah, we're definitely still discovering stuff. And actually that brings me back. This is a question I've been meaning to weave in for a while because it's great. It is, how can I get a job in astrobiology? I'm currently doing graduate research in astrobiology right now. That's kind of exciting. So do you have any advice for this viewer?
Yeah, I mean, so if they're already a graduate student, then they kind of already have an idea of what we're doing in astrobiology. Astrobiology is a huge realm of people working in fields like biology and chemistry and oceanography and astrophysics, but also in engineering and law and policy and even art and things like that. Like astrobiology requires a lot of us coming together to answer questions about what life is, where it comes from, what the future of life is here on Earth, to even ask questions like in psychology and things like that. Like, what is consciousness is a big question, and we don't have an answer to that yet. And so there's a lot when it comes to trying to figure out, like, if we're going to communicate with aliens, we have to understand language and how they might communicate via other languages or other forms of mathematics. There's a lot of questions out there, but if you want to be involved in astrobiology, the first thing to do is, so this person's attending graduate school, so they're working on a master's degree or PhD already. So that's good. So they're specializing in some realm of study. All of us have to do that. My specialty was geochemistry and mineralogy. But then all of us also have to learn these other languages of different sciences and different fields to start piecing things together. But then when it comes to doing the work, it really depends on what you want to do. So I'm still a research scientist. I still do publish research. I still get involved in various research realms, but I'm no longer in academia. And so for me personally, I've left the university. I'm no longer connected to a university, so I'm not a research professor. I work for a nonprofit and a research institution. And then I also do contract work with different groups through NASA and other organizations. And there's people like myself who do that kind of work. We work for nonprofits or work for for-profit companies in the industry, as it's called. There are people working at museums and planetaria. There's a lot of different things you can do with your career once you've earned your graduate degree that keeps you in the realm of astrobiology.
Yeah, one of our mutual friends actually does a comic book, an astrobiology comic book with NASA. So
yeah,
lots of possibilities. Yeah.
Yeah, actually, I have a bunch of those over here on my desk as well, since I give those out often when I go to meetings and stuff like that. I just give out comic books because they're great. And yeah, so there's a lot of ways to be involved in astrobiology. And honestly, like one thing I like to remind everyone is, like, even, school children, the elderly, everyone can be involved in this quest, because all you really have to have is curiosity about what's happening out there and what life is, and just join in the conversation and the dialogue around the world. about our quest to understand what it means to be human and what it means to try to understand life.
That's awesome. Okay, well, kind of like on that level, we're at our last question here. Thinking about, we've talked a lot, kind of thinking just about like what, the habitability of a planet, what, where life could evolve. But right now, do we also have telescopes on Earth that could receive alien signals, like from intelligent aliens that might be out there? What do you guys think? 3, 2, 1. Yes,
Yeah.
absolutely. We do. And Graham reminded me that the SETI Institute, which SETI stands for the Search for Extraterrestrial Intelligence, is not the only organization that's working on this, but that is one organization. If you go to SETI.org, that is one portal into this world where you can get access to data. I think you can even still like allow your computer to be used to analyze data. There's lots of opportunities, citizen science stuff that you can get involved with. And so SETI.org is one place to start that search. Now, we are going to look at the leaderboard to see who won, but please don't sign off right away because I also have 3 quick survey questions to ask. The CSA is curious to know. But let's go ahead and look at our leaderboard and see who has had this opportunity to win Science North passes or swag, if you're already a member. So here we go. Da, 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 da. And it looks like Spacey Lady has maintained her lead. Oh, yes. Well done. So 13,872 points. Excellent job. Please do go ahead and take a screenshot of your screen right now showing that you are the winner and email that to marketing@sciencenorth.ca. Renata's going to drop that into the chat so that you have it written down. And now, we will move on to our quick survey. And thank you to everyone who participated. You're all winners because I'm sure you learned something. We'll find out with the survey. So let's get into that. Just 3 questions. The first one is, did you have fun this evening with us? Was this an enjoyable experience? And we have some yeses on that. Thank you very much. And the next question is just for if you are under 18. So we only want to hear from the kids for this. Did you learn anything about Canada's activities in space? So was it new to you that we have instruments on the James Webb Space Telescope, one for the fine guidance sensor to point at things, and NIRISS, the near infrared slitless spectrograph, to actually look at the atmospheres of exoplanets for biosignatures, signs of life, and that we do have 450 hours of observing time with this amazing telescope here in Canada. All kinds of work. Some of you already knew all this, but I see for some of you that was new, so that's awesome. Always happy to share new things. I will also let you know, we mentioned the Artemis program. Canada is involved in that too. Canada Arm 3 contribution. Canadian astronauts going on Artemis 2. Okay, next question. After hearing this, participating in this, I know some of you were already super interested in science, technology, engineering, art, and math to begin with, and space. But are you a teeny bit more interested after this? Did it pique your curiosity? Awesome. Very good. All right. So even though I slide away, you can still answer these questions, I think, probably. And I would just like to right now give, we've got someone going to STEAM camp. Awesome. And art is a very big part of it, right? I showed you artists' renditions of, light traveling through the atmosphere of an exoplanet. It's, you have to be able to imagine these things and visualize them before you do them, for sure. And so I just want to give a moment here for Graham. Do you have any sort of last closing words, take-home messages? You've said some lovely and profound things already, but any last words for our
Yeah, I'll add on to the idea about art, and not just art, history, theater, philosophy. There's so much that we need to understand, not just the human condition and understand ourselves, and maybe to even be better for ourselves and better for each other, but also when it comes to understanding things like the universe and our place here on this planet. It's really important that we pursue these studies in art and history in those realms. And so one of my favorite scenes from a television show I watched a lot when I was a kid, which maybe isn't as popular for younger people now, but called Star Trek: The Next Generation. There's a scene where this captain of this fictional starship is speaking to a young man who's about to go off to school. The young man basically says like he didn't have time to read a book about history because it's not going to be on the exams. And the captain says to him, like most of the important things in life won't be. That anyone can learn things like physics and calculus and the mechanics of flying a starship or flying a spacecraft, but understanding history and philosophy, it makes all of this make sense. And when he says that, he looks out into the stars beyond them, into the cosmos. And that's something I've always held that comment near and dear to my heart, because even though, yes, I've studied lots in the sciences, I've learned a lot over the years. I spent 13 years in university earning my degrees. At the same time, coming back to art and poetry and philosophy has always helped me to ground myself and to be a better version of myself. And so we definitely need people who are also artists and philosophers to join in this quest to understand life.
Awesome. Well, it was certainly wonderful to have you here with us this evening. Thank you so much. And thank you to everyone out there for joining us. Just want to let you know this program was once again undertaken with financial support from the Canadian Space Agency. If you did like the content, you can donate through Eventbrite, you can subscribe for more content. And just finally, thank you, merci, miigwech, and keep looking up.